Hey guys, welcome back. In most real-world scenarios, when it comes to Hive, you will be using files with formats other than text. So knowing how to use Hive with other file formats is crucial, especially since Hive is a popular tool of choice in the Hadoop ecosystem for a lot of companies. In this lesson, we are going to learn how to deal with three types of file formats in Hive. The first one is compressed file, second sequence file, and finally Avro files. Within each file format, we will see how to write and read to and from Hive tables. When I say read, I mean a simple select from a Hive table, and when I say write, I mean inserting into a Hive table. Let's look at compression first. Working with compression files is straightforward in Hive. All you have to know is the codec that is used for compression, and Hive will work with compressed files seamlessly. As you already know, you can enable compression in a couple of places. With this example, I'm going to enable the compression at the map output and also at the final output of the MapReduce job. And you can enable compression using these set of properties that is highlighted on the screen. Here, I'm enabling the compression at both the intermediate level, that is the map output, and also at the final output. The compression codec that we will be using is gzip codec. Let's go ahead and set these properties in our Hive session. There you go, all the four properties are now set. Now I'm going to create a table using the create table as select expression. Let's take a look at the syntax of this create. As you can see, you don't have to specify a file format or anything specific to compression while creating the table, because we have already set the properties to enable compression and we have already specified the codec. When you execute this query, a table named stocks_comp on GC will be created with the same structure as stocks, and the data from the stocks will be copied over to the stocks comp on GC table. Let's now execute this query in our cluster. The create statement will result in a MapReduce job, and since you have enabled the compression at the output level already, the data from the stocks table will be compressed and stored in the stocks_comp on GC table. Let's wait for the execution to complete, and then let's review the output. Now this newly created stocks comp on GC table will be pointing to a data set which is compressed. So let's make sure that is in fact the case. So I'm going to do an fsls on the location of this table. And as you can see, the files under this location are stored in .gc format, which is nothing but files compressed using gzip codec. Now, any guesses what will happen when I query the stocks comp on GC table? Very simple. Just like a MapReduce program or PIC script, you do not have to do anything special to deal with compression, as long as the data set or files has an extension that is valid and can map back to a codec. In our case, the file has the extension .gc, and the default file format, in this case the text input format, will automatically use the proper codec associated with extension gc. In this case, gzip codec. So let's try a simple select on this table. I'm also going to limit the records to 1000. There you go. The result from the compressed files is listed in plain text readable format. That was easy, wasn't it? Dealing with compression is super easy, both in PIG and both in Hive, and even with traditional MapReduce. Let's look at sequence files now. This is what we're going to do. We're going to create a table that is designed to handle sequence files. And then we're going to insert records into the table. Once inserted, we're going to look at how the inserted data is stored in HDFS. This demonstrates a write operation. Then we are going to do a select on the table and see how Hive reads a sequence file and display the output. This demonstrates a read operation. Are we on the same page? Okay, let's look at the create table syntax. This table is designed to handle sequence files. The only additional thing you see here in the syntax is stored as sequence file at the very last line. This indicates that the file format for this table is sequence file, and Hive will appropriately assign the input and the output format that are specific to the sequence file. So let's go ahead and create this table. The table is now created. Now let's run a describe formatted on the table and check the input and the output format. As you can see, the input and the output format used for this table will be sequence file input format and Hive sequence file output format. As we know, you can enable compression for sequence file at the record level or at the block level. Just to keep things interesting, I'm going to enable block level compression using this set statement. Let's set the compression type to block in our Hive session. Now we have a table ready and the compression is set at the block level. Let's run an insert statement to select all the records from the stocks table and insert them into the newly created stocks_seq table. Let's run this insert statement now. Let's wait for the execution to complete and we'll review how the file is stored behind the table. Let's do a Hadoop ls listing on this location right here, which is the location pointed by the table. We can see two files at this location. Just to make sure they are written in sequence file format, let's bring down these files locally and let's open the file and make sure they are in fact sequence files. So I'm going to copy the file locally using copy to local. And I'm going to do a VI on the file to open the file. As you can see, the file is not readable, but you can see the sequence file header right here, which confirms that it is in fact a sequence file. Now, do you have any doubts what will be the output when we query the stocks_seq table? Why doubts? Let's query the table. There you go. The output is readable just like reading from a text file. The sequence file input format did a great job reading the sequence file and displayed it nicely in human readable format. This demonstrates how we can deal with sequence files in Hive. Okay, let's move on to the next file format in our list, Avro files. As we looked in the Avro lesson, Avro files are defined using a schema. To create a Hive table to deal with Avro files, we need to first store the Avro schema in HDFS. I have already stored the Avro schema in HDFS in this location right here. So this schema defines the stocks dataset. So why don't we go ahead and look how the schema would look like. Here's the schema for our stocks dataset. It is exactly the same schema that we use with the pig scripts as well. So now let's go back and look at the create table syntax to create an Avro table. When you create an Avro table, the columns for the Avro table will actually come from the schema. So you do not have to specify the columns individually in the table because we will be specifying the schema file using the table properties like this right here. So the table property avro.schema URL will point to the schema in HDFS. In addition to the schema, we have to provide the SERDI input and output format for Avro. With this information, Hive will know how to interact with Avro files. The input format in this case is going to be Avro container input format, and the output format in this case it's going to be Avro container output format. And the SERDI will be Avro SERDI. Let's go ahead and create this table. Now, just like we loaded the other tables, we'll load the stocks_Avro table as well by selecting the records from the stocks table and inserting them into the stocks_Avro table. So this insert select statement will select all the records from the stocks table and will insert them into stocks_Avro table. So let's wait for the execution to complete and then we'll review the output. The insert is now complete. Let's bring down the file behind this table from HDFS and open the file to look at the file content. Again, I'm going to use the copy to local command to bring the file from HDFS to local. Let's remove the old file. Let's bring the new file, that is for the Avro. Let's open the Avro file now. As you can see, this file is not in a readable format And from the header, you can also see there is an Avro schema. So this file for sure is written using Avro. Now that demonstrates a write operation for Avro files. Why don't we do a select and demonstrate the read operation as well? There you go, perfect results in readable format. That's simple. Let's look at the create syntax for the stocks underscore Avro table again. Let's say you come up with your own custom file format. All you need for a Hive table to work with the new file format is a SERDI input format and output format defined for your specific file format. That is it, and Hive would know how to work with the files. So let me summarize what we learned in this lesson. We looked at how Hive can work with different file formats like compressed files, sequence, and Avro files. We now know how to create, read, and write to tables which can handle file formats which are not text using Hive. With that, let's end this lesson. See you in the next lesson.